Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@yvcc.edu and I will respond as soon as I can. Alrighty, today we're going to be wrapping up this chapter. We're going to look at section 9.5, and then tonight's assignment will be 9.5 as well as the chapter review. Tomorrow, which is Thursday, we'll review for the test, and Friday will be the test. All right, but before we get into all of that, I have some questions from you folks concerning section 9.4. So this is 9.4, number 20. It says multiply and simplify. All right, and we have the following. We have 3 times the cube root of 9 minus 3 times the cube root of 3. All of that times 3 times the cube root of 9 plus 3 times the cube root of 15. So we're going to FOIL these together. We're going to get 4 products, and then we're going to simplify each of those. So first of all, we're going to take that times that. So we get 3 cube roots of 9 times 3 cube roots of 9. Okay, so let's see, what would that give us? Well, we'd have 3 times 3 is 9. Cube roots of 9 times 9 times 9 times 9 is 81. Okay, but that could be written as 9 times the cube root of 81 is 3 times 3 times 3 times 3. So 3 to the 3rd power times 3 to the 1 power. Okay. And that's going to be, let's see here. We're going to take the cube root of 3 cubed, and that's going to give us a 3 outside. So we're going to get 27 cube roots of 3 for our first product. Does anybody have any questions about how I got that first of 4 products? Okay, now we're going to take this one times that one. And so we're going to get plus 3 cube roots of 9 times 3 cube roots of 15, which will give us 9 cube roots of, okay, 9 would be 3 times 3, and 15 would be 3 times 5. So I'm pulling this down into here and this down into there. Okay, so that would be 9 cube roots of 3 cubed times 5, which would be 9. Oh, the cube root of 3 cubed would be 3, and then I've got the cube root of 5 left over, so 27 cube roots of 5. So there's our second product. Any questions there? All right, next we're going to do this one. So we're going to get minus 3 cube roots of 3 times 3 cube roots of 9. Oops, I wrote that incorrectly. Let me fix that. All right, times 3 cube roots of 9. So that's going to be minus 9 cube roots of 3 times a 9 would be 3 times 3. So that would be minus 9 cube roots of 3 cubed, which would be minus 9 times 3, which would be minus 27. Any questions there? And finally, the last times the last, which is going to be, let's see, minus 3 cube roots of 3 times 3 cube roots of 15, which would be minus 9 cube roots of 3 times 3 times 5. Oh, that's not going to go anywhere. Minus 9 cube roots of 45, because there's nothing inside of there I can simplify. So here is our final answer. We've got those 4 terms. And they don't have to be in that order. Any questions? Okay, that was number 20. Let's take a look at number 21, which is very similar. Okay, so 9.4, number 21. And we have the cube root of 7z plus the cube root of 2 times the cube root of 7z plus 8 cube roots of 2. Okay. Same idea. We're going to FOIL it. So we're going to take the first times the first. Let's see here. And that's going to give us the cube root of 7z times the cube root of 7z. Let's see. So that would be the cube root of what? 7 squared z squared. And I can't really do anything more with that because 49, 7 times 7, it's not a cube. Z squared, z times z, it's not a cube. So that's as far as I can go with that first term. So I'll tell you what, we'll just bring it all the way down here. Cube root of 49 z squared. Okay. Then we're going to take the first one times the last one. And we're going to get plus the cube root of 7z times 8 cube roots of z. Okay. And that's going to be plus 8 cube roots of 7z squared. Let's see here. Yes, I see I've made a mistake, and that is in my copying. This thing right here, I took to be a z, and it's supposed to be a 2. Once again, my sloppy writing does me in. Sorry about that. Let's see if I can clean this up. All right, this is 8 cube roots of 2. 8 cube roots of 2. Okay. We okay now? So this is going to give me 8 cube roots of 14z. 7 times 2 times z. Again, nothing I can do there. All right. Moving on, we'll take that one times that one, which gives us plus cube root of, let's see, is that a 2? That's a 2. Cube root of 2 times cube root of 7z. That's going to be plus the cube root of 14z. The reason I'm going is because I'm looking at the answer that they have, and their answer is not correct. Interesting. We'll talk about it when we get there. Okay, it isn't wrong. They just, anyway, we'll talk about it. All right. Any questions? So that's going to be plus cube root of 14z. And then we're going to take that one times that one, which is going to be plus the cube root of 2 times 8 cube roots of 2, which is going to be 8 cube roots of 2 times 2, or 4. Now, this is the answer that they have written as the correct answer, not the student that asked about it, but this is the answer that they've got. What's wrong with this? Why is this not correct? Can anybody tell me? It isn't done.
You can add the cube root of 14z.
And the 8th, yeah, which is really odd to me because, like I say, what I'm looking at has the answer written and it has that not combined. So really the correct answer should be the cube root of 49z squared plus 9 times the cube root of 14z plus 8 times the cube root of 4. Okay, because these two should be combinable. Let me just show you here what I'm talking about. I don't know why they have that. See right here? These two, those two are like terms, aren't they? Yeah, so I don't know. Anyway. All right. So now, let's see, that was 21. We're going to go on to 27. And here we have the quantity, the square root of 2x plus the square root of 2, the quantity squared. Well, that's basically the square root of 2x plus the square root of 2 times the square root of 2x plus the square root of 2. Because you've got two factors of the square root of 2x plus the square root of 2. So now we're going to FOIL those together. We're going to get the square root of 2x times the square root of 2x, okay, which is going to be what? 2x, right? Okay. Then we're going to take the square root of 2x times the square root of 2, so plus the square root of 2x times the square root of 2. Careful. So that would be plus 2 square roots of x. Are we okay where I got that? Because the square root of 2 times the square root of 2 would be 2, and then the square root of x is still the square root of x. Okay, and then this one would be plus the square root of 2 times the square root of 2x. That's going to be 2 square roots of x. And then the square root of 2 times the square root of 2, which would just be 2. These are combining our like terms, so we get 2x plus 4 square roots of x plus 2 as our final answer. Okay, 32 coming up. We good to go? All right. Rationalize the denominator. All variables represent positive real numbers. So we've got the square root of 40x squared over the square root of 8x squared y. I think what I would do is I'm going to rewrite this as a single square root with a fraction inside. Then I'm going to reduce that down. 40 over 8 is 5. X squared over x squared is just 1. So I've got the square root of 5 over y, which is the square root of 5 over the square root of y. Now I'm going to multiply by the square root of y over the square root of y, which gives me the square root of 5y over y. And there's my final answer. Any questions about that one? Okay. Here we have 9.4, number 39. Oh, let's see, there's a part A and a part B. So this is part A. We have 8 times the square root of x minus 6, the quantity squared. So that's 8 times the square root of x minus 6 times 8 times the square root of x minus 6. Okay. Well, I could write this like this. Let's see if this helps. This is 8 times the square root of x minus 6 times 8 times the square root of x minus 6, right? But I could commute things and write it as 8 times the square root of x plus, oh, not x plus, x minus 6, square root of x minus 6. Well, this would be 64, and this would be x minus 6. So distributing, I get 64x minus, what is that, 363.84? So there's the answer to part A, 64x minus 384. Any questions there? Okay, let's take a look at part B. And that is 8 plus the square root of the quantity x minus 6 squared. So this first one was 8 times it. This is 8 plus it. So now we've got 8 plus the square root of x minus 6 times 8 plus the square root of x minus 6. 8 times 8 is 64. 8 times that would be 8 square roots of x minus 6. The square root of x minus 6 times 8 would be 8 times the square root of x minus 6. And the square root of x minus 6 times the square root of x minus 6 would be x minus 6. Combining like terms, I get 64 plus 16 square roots of x minus 6 plus x minus 6. Oh, but I can put these two together. Let's see. I'm going to go x plus 16 times x minus 6, and then plus what, 58, the 64 minus 6. So that would be the final answer. All righty. So that was that person's questions. And I've got one other person's questions here. So let's take a look at that. Let's see. 4781. And there. 9.4. Come on. Things are moving slowly here. All right, number 21. This is just like one I did, except interestingly enough, the student that asked about it had the right answer, but the answer off to the side, again, they didn't combine some like terms. Do you still want me to do this?
Is it mine?
Yes.
No, I realized that I didn't pay attention to the index, and I didn't realize it was a cube root. So.
Okay. Well, I'll go ahead and do 38 though.
Okay, thank you.
Yeah, because you did have the right answer there. All right, so this is, what is this? 9.4, number 38. Perform the operations and simplify if possible. The variable represents a positive real number. Okay, so we've got the square root of x times x plus 5. It's a little bit longer than it needs to be. And then we've got the square root of x cubed times x plus 5. Well, So multiplying two radicals with the same index, we could write them as a single radical, and inside we get x to the fourth, x plus 5, the quantity squared, like that. So then, let's see here. What do we get there? Ah, I see what they did. Okay, so this is going to be what? X squared times x plus 5, because the square root of x to the fourth would be x squared. The square root of x plus 5 squared would be x plus 5, okay? But then we'd get x cubed plus 5x squared as our final answer, because you could FOIL or distribute that further. All righty? Well, that's all the questions that were requested ahead of time. Do either of you have any other questions you'd like to look at before we go on?
No.
All right, well then we'll go on to section 9.5. Maybe, okay. So what we're going to be doing in 9.5 is solving radical equations. So we'll have some equations that'll have some square roots or cube roots or other roots in it. All right, now, this first example, we've got the square root of x minus 10 equals 1. Radical equations are similar to absolute value equations, in which we did earlier, in that if you have an equation with one radical, you want to isolate that radical first, okay? And this problem already has that done. Now, since on the left side of the equation we have a square root, I'm going to square both sides of the equation. On the left side, the square root of x minus 10, the quantity squared, would be x minus 10. On the right side, 1 squared is 1. Now, whenever we solve an equation by squaring both sides or cubing or raising both sides to the fourth power, etc., there's always the potential to introduce what are called extraneous solutions. Those are solutions that we come up with, but when we check them, they don't work. And in WebAssign, they will ask you to solve an equation. Then they'll say, are the solutions extraneous or not? If they're extraneous, they don't work, kind of thing. But they'll ask you to find them and then check whether they work or not, okay? Now, going on with this equation, I'm going to add 10 to both sides. So I get x equals 11. Let's check our work. Let's see, if x is 11, we would have that. Plugging 11 in there. So then we get the square root of 1 equals 1, 1 equals 1, it checks. So this is not an extraneous solution, meaning that it does work. Any questions about that one? Okay. Let's take a look at this problem. We have the square root of 2a minus 3 plus 3 equals a. And the plus 3 is outside of the radical. All right, so once again, the first thing we want to do is isolate the radical. So we'll subtract 3 from both sides, which gives us the square root of 2a plus, the square root of 2a minus 3 equals a minus 3. I need to slow down here. Now, because we have a square root, we're going to square both sides. On the left side, I get 2a minus 3. On the right side, be careful, I don't get a squared plus 9 or whatever, because this would be what? A minus 3 times a minus 3, which if you FOIL it together would be a squared minus 3a plus 9. Okay? Combining like terms on the right-hand side, I get 2a minus 3 equals a squared minus 6a plus 9. Any questions so far? Now, this is a second degree equation because of the a squared. So to solve it, I'm going to put everything on one side, set equal to 0 on the other side, and then factor it if I can. So I'm going to put everything on the right side. So I'm going to subtract 2a from both sides and add 3 to both sides. So 0 equals a squared minus 8a plus 12. Factoring that, I get, let's see, a minus 6 and a minus 2, I believe. So then if a minus 6 equals 0 and a minus 2 equals 0, adding 6, we get a equals 6. Adding 2, we get a equals 2. So I have two potential solutions, 6 and 2. Any questions about that? All right, what I'm going to do is I'm going to recopy the original problem. So this, and then our proposed solutions on the next page so that I have more room to work with. Okay, so the square root of 2a minus 3 plus 3 equals a. Is that correct? Yes. And then a is 6, a is 2. A equals 6, a equals 2. All right, so now I'm going to plug 6 in the place of a. So I'll get the square root of 2 times 6 plus 3 equals 6. The square root of 12 plus, oh, wait a minute. I left out an important part there, didn't I? Equals 6. The square root of 9 plus 3 equals 6. 3 plus 3 equals 6. So this one checks. Okay? Let's check the other one, the 2. The square root of 2 times 2 minus 3 plus 3 equals a. The square root of 4 minus 3 plus 3 equals a. The square root of 1 plus 3 equals a. Oh, what did I forget to do? I forgot to put the 2 in the place of a. Looks like I'm having a Monday here. Okay, sorry about that. We get 1 plus 3. My problem is I'm thinking ahead to the fact that this one doesn't work. So 2 is an extraneous solution. Okay? So you come up with 6 and 2. 6 works, 2 does not work. Any questions about that? And again, in WebAssign, they may ask you very specifically, you know, what are the solutions? Does this one work? Does it not work? Is it extraneous, etc., etc.? Okay. Let's take a look at another problem. See if I can redeem myself here. Maybe, maybe not. We have the square root of 3x plus 5 equals 2. So in the directions say solve each equation, write all proposed solutions, cross out those that are extraneous. That's out of the textbook. On WebAssign, I think you label them. It asks you specifically. I have an equation with one radical. I'm going to isolate that radical. So I'm going to subtract 5 from both sides, and I get this. Now, consider this. When you take an even root, you can't get a negative answer. So the square root of 3x cannot equal -3. So I already know something's not right, okay? But let's continue on. Now I'm going to square both sides, and I get 3x equals 9. Divide by 3, x equals 3. Let's plug that in. I get the square root of 9 plus 5 equals 2. 3 plus 5 equals 2, 8 equals 2. So that had one solution, which was 3, but extraneous, so there is no solution, which is what I mentioned earlier, because we end up with a square root equal to a negative number. Okay? But they may ask you to find that solution and then check it to see that it doesn't work, rather than just write no solution. All right, now let's take a look at this case. We have the cube root of the quantity 12m plus 4 equals 4. Again, we have one radical. It's isolated already. But now, what are we going to do to solve it? Are we going to square both sides?
No, we're going to cube both sides.
We're going to cube both sides. So we get 12m plus 4 equals 4 times 4 is 16 times 4 is 64. Subtract 4 from both sides, 12m equals 60. Divide by 12, m equals 5. Let's check it. If m is 5, we get the cube root of 12 times 5 plus 4 equals 4. The cube root of 60 plus 4 equals 4. The cube root of 64 equals 4. The cube root of 64 is 4. 4 equals 4. So this is a correct solution. Okay. Let's see here. How about this one? It says let f of x equal the fourth root of the quantity 3x plus 1. And then it says for what value or values of x is f of x equal to 4. So once again, we're going to take this and put it in the place of f of x. So our equation becomes 4 equals the fourth root of 3x plus 1. We have one radical. It's already isolated. So we will raise both sides to the fourth power. Well, let's see. 4 to the fourth power, I believe that's 250. Yeah, 256 equals 3x plus 1. Subtract 1, 255 equals 3x. Divide by 3, x equals, let's see, is it 85? Yeah, 85. Okay, let's check that to see if it works. So 4 equals the fourth root of 3 times 85 plus 1. 4 equals the fourth root of 255 plus 1. 4 equals the fourth root of 256. And the fourth root of 256 is 4. 4 equals 4. The answer checks. Okay. Now, let's say we've got an equation with 2 radicals in it. For instance, this one. The square root of 6 minus 2x equals the square root, 4 times the square root of x minus 3. We have an equation with 2 radicals, only 2 terms, both of which have radicals in them, because the 4 is part of that second term. If we have 2 terms, we want them separated, one on each side of the equal sign, which is what we've got right now. Since they're square roots, we're going to square both sides. On the left side, I get 6 minus 2x. But on the right side, I got to be careful, because not only are we going to square the square root of x minus 3, we're also going to square the 4. We have a product raised to a power, so that 2 gets attached to the 4 and to the square root of x minus 3. So we end up with 6 minus 2x equals 16 times x minus 3. Everybody okay with that? 4 to the second power was 4 squared or 16. The square root of x minus 3 squared is x minus 3. So then we get 16x minus 48. So far, so good? Okay. I'm going to add 2x to both sides. 6 equals 18x minus 48. I'm going to add 48 to both sides. 54 equals 18x. Divide by 18x equals 3. Okay, let's check our work. The square root of 6 minus 2 times 3, which is the square root of 6 minus 6, which is the square root of 0, which is 0, equals 4 times the square root of 3 minus 3, which is 4 times the square root of 0, which is 4 times 0, which is 0. So x equals 3 checks. Okay. Let's look at some formulas. We have this formula, d equals 1.4 times the square root of h. And we want to solve this for h. Now, I have one radical term, and it's isolated, because the 1.4 is just like the coefficient of that. It's still part of that term. I need to isolate h. I could square both sides and then get rid of the 1.4 squared by dividing both sides by it. Or I could divide both sides by 1.4 first and then square both sides. So what do you want to do? Do you want to divide first or square first? You tell me.
Square.
Okay. So I get d squared equals 1.96h, because 1.4 squared is 1.96, and the square root of h squared is h. Now I'll divide both sides by 1.96. So h equals d squared divided by 1.96. Questions there? Okay, let's take a look at another one. D equals the cube root of 12v over pi, and we're supposed to solve for v. Okay, now, again, the radical is isolated. So I'm going to cube both sides. On the left, I get d cubed. On the right, I get 12v divided by pi. Cubing the cube root takes care of the cube and the cube root. I'm solving for v. So now I'm going to multiply both sides by pi. So I get pi d cubed equals 12v. Then divide both sides by 12. So v equals pi d cubed over 12. Any questions there? Okay, let's see here. How are we doing? This says, let s of t equal the square root of t plus 8, and h of t equal, let's see, hang on. Oh, nope, sorry, can't do that one. It opens up a can of worms. My bad. Hang on. We can do this one. Okay. The reason I'm not doing that one is because it leads us to something that's more complicated than we need to do. Let f of x equal the fourth root of x plus 8 minus the fourth root of 2x. Okay. Find all values of x for which f of x equals 0. So once again, we're going to take that and replace that with 0. So our equation becomes 0 equals the fourth root of x plus 8 minus the fourth root of 2x. We have an equation with two radical terms. So I want to separate them. And so that I have positive coefficients, I'm going to add the fourth root of 2x to both sides. So on the left side, I get the fourth root of 2x. On the right side, I get the fourth root of x plus 8. Okay. So now I've got a radical on one side, a radical on the other side. I'm going to raise both sides to the fourth power, which gives me 2x equals x plus 8. I'm going to subtract x from both sides, and it gives me x equals 8. And now let's check our work. If x is 8, we get 0 equals the fourth root of 8 plus 8 minus the fourth root of 2 times 8. 0 equals the fourth root of 16 minus the fourth root of 16. Okay, the fourth root of 16 is 2, but even without finding that, wouldn't the fourth root of 16 minus the fourth root of 16 be 0? So it checks. All righty. So that wraps up section 9.5, as well as the stuff we're going to cover in this chapter. So again, your assignment tonight, you've got 9.5 in the chapter review. I'll be back this afternoon at 1:15 for an office hour if you need me then. Tomorrow during class time, we will review for the test. And then on Friday, there'll be no class meeting at 11:30. You'll just take your test sometime Friday before 11:59. All righty, I'm going to stop the recording.